There are moments in science when reality feels stranger than fiction. One of those moments arrived quietly, almost unnoticed by the wider world, when astronomers reported a bizarre discovery. A strange visitor from the dark beyond. An object that did not belong to our solar system, moving too fast, too freely, to ever be tethered by our sun. It was named 3I Atlas. To most people, that name sounds clinical, almost forgettable, like a string of letters and numbers from a catalogue. But behind it hides one of the most intriguing questions of our time. Could this visitor have come not by chance, but by design? Could it, in ways we can scarcely prove, have been watching us? The appearance of 3I Atlas is one of those cosmic events that makes us reevaluate everything we think we know about the universe. Space is not empty. It is filled with wandering objects, asteroids, comets, icy fragments, dust. Yet most of these belong to our own system, birthed billions of years ago from the same swirling disk of matter that formed the Sun and planets. What makes 3I Atlas different is that it came from somewhere else, somewhere out there. An interstellar traveler, plunging across the void, cutting through our planetary neighborhood before vanishing again into the deep. The mystery begins with the fact that interstellar objects are staggeringly rare to detect. For all of human history, our skies have been filled with meteors and comets streaking past. But nearly all of them loop back, bound by the sun's gravity, cycling in predictable paths. An interstellar object, by contrast, is an intruder. Its trajectory is open-ended, a hyperbolic curve that ensures it will never return. For centuries, astronomers speculated such things must exist, but we had never seen one. Then suddenly, in just a few years, we saw not one, not two, but three. And that is what makes 3I Atlas so tantalizing. It is the third member of a strange and exclusive club, a trio of known interstellar visitors, the famous Oumuamua in 2017, the comet Borisov in 2019, and finally 3I Atlas in 2020. That short interval raises eyebrows. Why now? Why in the age of modern telescopes and digital detection are these wanderers suddenly entering our story? Is it pure coincidence, or are we at the cusp of a larger revelation? When astronomers first spotted 3I Atlas with the Asteroid Terrestrial Impact Last Alert System, known as ATLAS, it seemed at first like just another faint smudge of light against the starry backdrop, but its motion betrayed it. Unlike objects tied to the sun, it was racing along a trajectory that proved it was a foreigner. Its speed and angle could not be explained by any orbit inside our system. This was no homegrown comet. This was a messenger from afar. And yet, unlike its predecessors, 3I Atlas was elusive. By the time we realized what it was, it had already fragmented. A delicate, ghostly object, it broke apart before detailed studies could be made. Only fragments of data remain, measurements, orbital parameters, hints at what it may have been. But those few traces have left us with more questions than answers. Was it a fragile comet ripped apart by the sun's pull? Or was its destruction a deliberate act, as if shedding its disguise before slipping away unseen? That lingering uncertainty is what gives 3I Atlas its haunting allure. We know it came from beyond. We know it was not bound to our star. We know it came and went so fast that only fleeting glimpses were possible. But what we don't know, what we may never know, is its true nature. And when knowledge is scarce, imagination fills the void. Could it have been more than just ice and dust? Could it, in some unfathomable way, have been watching us? Because when something alien enters your world, the mind cannot help but wonder, was it an accident, or was it intentional? When astronomers first identified the faint blur of light that would come to be known as 3I Atlas, it didn't immediately reveal its secret. At a glance, it looked like countless other icy bodies that populate the solar system, drifting slowly in the outer reaches. But when its trajectory was measured, the truth became undeniable. This was not one of our own. The path it carved through space was hyperbolic, meaning it wasn't looping around the sun like a comet or asteroid. It was on a one-way journey, cutting through and then leaving forever. That single fact alone places it in the rarest category of celestial visitors, an interstellar traveler from beyond the cradle of our solar system. The name itself carries meaning. The 3I stands for the third interstellar object ever detected by humanity, following in the footsteps of Oumuamua in 2017 and Borisov in 2019. The Atlas part comes from the system that discovered it, the Asteroid Terrestrial Impact Last Alert System, a network of telescopes in Hawaii designed to scan the skies for incoming threats. Ironically, instead of catching a dangerous asteroid, Atlas happened to capture something far more exotic, a wanderer from the deep interstellar void. What made 3I Atlas fascinating is that it bore many of the hallmarks of a comet. Observations showed it had a faint, diffuse tail of gas and dust, a coma, suggesting it was made of volatile ices that vaporized as it neared the sun. Unlike Oumuamua, which puzzled scientists by showing no visible outgassing despite its comet-like motion, 3I Atlas did seem to behave more like the comets we know. Yet even within that familiarity, there was strangeness. The object fragmented unusually quickly, breaking into pieces before it could be studied in depth. To some, this was simply the sign of a fragile body, one that may have been battered by countless collisions during its long voyage between the stars, and was too weak to survive the sun's gravitational stress. To others, its disintegration only deepened the mystery. Was this truly a comet that happened to wander into our solar system? Or was there something unusual about the way it fell apart, almost as if shedding layers before vanishing into the night? Because of the brief window in which it could be observed, astronomers were left with only fragments of data, estimates of its size, suggestions of its composition, and calculations of its orbital parameters. It was believed to be a few hundred meters across before it split, making it smaller than many of our familiar solar system comets, but still large enough to be visible across millions of miles. Its speed, calculated at tens of kilometers per second, confirmed its interstellar origin. No object bound to our sun could have entered with such velocity. It was as if it had been wandering the galaxy for eons, until sheer chance brought it across our path. Yet in that chance lies one of the most haunting aspects of 3I Atlas. We saw it only briefly, only faintly, before it was gone. Unlike Borisov, which gave astronomers months of observation, or Oumuamua, which stuck around long enough to stir heated debates, Atlas came and went in a blur, leaving more speculation than certainty. And in science, gaps in certainty create fertile ground for imagination. If we strip the mystery away, the simplest explanation is that 3I Atlas was a fragile interstellar comet, a shard of ice and rock ejected from some distant star system, doomed to wander endlessly until its body fell apart. But if we allow ourselves to sit with the mystery, the story shifts. Its sudden appearance, its brief visibility, its strange fragmentation, all of these details invite us to ask whether we truly understood what we were looking at. Could it have been something more than it seemed, something concealed beneath the cloak of a natural object? That is the essence of 3I Atlas, an object not bound to our sun, detected only in passing, fleeting in its visit, yet profound in its implications. It is the kind of cosmic encounter that forces us to confront how little we know, how much we miss, and how vast the possibilities remain when something alien enters our skies. When scientists realized that 3I Atlas was not unique, but the third member of a growing list, the discovery became part of a larger story, a story some now call the Interstellar Club. Before 2017, the very idea of seeing an interstellar object within our lifetime seemed almost impossible. Astronomers knew such wanderers must exist, fragments ejected from young planetary systems, scattered by gravity, doomed to drift endlessly between the stars. But they were thought to be so rare, so faint, and so fleeting that the chance of one entering our view was slim. Then came Oumuamua. Oumuamua arrived in October 2017, a silent, elongated object slipping through our solar system on a hyperbolic path. Its Hawaiian name translates to scout or messenger from afar, and that name has proven hauntingly fitting. Unlike any comet or asteroid ever seen, it displayed a bizarre shape, tumbling end over end like a cosmic baton. More confounding still, it showed no obvious coma, no tail, no outgassing, yet its trajectory shifted as though something invisible was pushing it. Radiation pressure from the sun? Sublimation too faint to detect? Or, as some dared to suggest, was it a sail, a thin artificial structure using starlight itself as propulsion? Harvard astronomer Avi Loeb famously argued for that possibility, igniting controversy. Suddenly, the world was not just asking, "What is this rock?" but "Could this be technology?" Oumuamua forced mainstream science to confront an uncomfortable question. How do we know what is natural and what is not, when we have so little to compare it to? 2 years later, just as the debates about Oumuamua were still raging, another stranger arrived. In August 2019, amateur astronomer Gennady Borisov discovered a bright, active comet streaking into the solar system. This one, unlike Oumuamua, looked more familiar. It had a coma, a tail, and volatile gases venting from its surface, classic cometary behavior. And yet its trajectory was again hyperbolic, proving it too was an interstellar visitor. Borisov reassured many that perhaps interstellar objects are indeed just icy remnants, natural shards wandering the galaxy. But it also posed new questions. If one was cigar-shaped and strangely silent, and another looked like a typical comet, how much diversity exists out there among the relics of alien star systems? And how many different forms could such travelers take? Then came Atlas in 2020, completing the triad. The first three confirmed interstellar visitors, appearing one after another in such a short span, felt like a revelation. Had they always been slipping through unnoticed until our technology improved? Or were we suddenly in a moment of cosmic convergence, a period when the galaxy seemed to be sending us fragments, whether by chance or by intent? The odds of spotting three so close together stretch the imagination, especially given that for centuries we had spotted none. Each member of this interstellar club raised its own set of eyebrows. Oumuamua unsettled scientists by not behaving like anything we had seen. Borisov proved that at least some were more comet-like, yet its sheer brightness and activity were unusual even by comet standards. Atlas arrived fragile and fleeting, breaking apart before its nature could be pinned down. None of them fit neatly into the boxes we had prepared, and in that sense, they opened a Pandora's box of possibilities, where natural explanations brush up against the unsettling notion that perhaps, just perhaps, some of these visitors are not mere accidents of gravity and time. This is the strange company 3i Atlas keeps. A mysterious scout that defied physics, a roaring comet that seemed too energetic for its size, and now a fragile wraith that crumbled before our eyes. Three pieces of a puzzle that might represent the galaxy's endless debris, or might be the first glimpses of something deliberately passing through. The deeper we go into the strange case of 3i Atlas, the more we come face to face with the question that lingers unspoken in so many scientific discoveries. What if this wasn't just another space rock? What if it was something else, something watching, something with intention behind its flight? This is the alien question, the central mystery that transforms a fragment of ice and dust into a subject of cosmic intrigue. On the surface, the simplest explanation is always the most comfortable. 3i Atlas was a natural object. It came from some distant planetary system, ejected long ago by the gravitational chaos of forming planets, and after millions or billions of years drifting in the void, it happened to cross paths with our solar system. That scenario requires no advanced civilizations, no conspiracies, no cosmic games of hide and seek, just physics, time, and chance. And yet, Even within that natural explanation, something stirs unease. Why did it fragment so quickly, leaving us unable to properly study it? Why did its fleeting appearance come so soon after two other interstellar wanderers, when for centuries we had seen none? And most importantly, how do we distinguish between what is merely natural and what could be designed, when our evidence is so scarce? The human mind is drawn to patterns, to possibilities, to the gaps in knowledge where imagination can thrive. In the case of Oumuamua, the suggestion that it might be artificial was enough to ignite global headlines and fierce debate within the scientific community. Some argued that extraordinary claims require extraordinary evidence, and since no radio signals, no heat signatures, no definitive traces of technology were detected, the idea of alien design must be dismissed. Others countered that the very strangeness of its trajectory, the very absence of typical cometary behavior, was extraordinary evidence that if we refuse to even consider non-natural explanations, we may blind ourselves to realities we don't yet recognize. When Atlas entered the stage, those same tensions resurfaced. Here was an object that looked more like a comet, that seemed less strange in its behavior, but that still raised questions because of its fragile nature and sudden destruction. To the cautious, this was just another data point in the growing catalogue of interstellar fragments. To the imaginative, it was another opportunity to ask, could these be scouts, probes, even messengers designed to look like the debris of space, slipping past our notice while silently carrying out their missions? The alien question does not arise merely from paranoia or fantasy. It arises from a deep awareness of our own limitations. Think about the scale of our galaxy. Hundreds of billions of stars, each with planets, moons, and debris fields of their own. If life has arisen here on Earth, why not elsewhere? And if elsewhere, why not civilizations older and more advanced than ours? We ourselves are already imagining ways to send probes to interstellar space, tiny light sail craft that could cross the distance to nearby stars within decades. If we are just beginning to think of such things now, could not others, millions of years ahead of us, have already seeded the galaxy with watchers, probes, and messengers disguised as natural wanderers? And what better disguise could there be than a comet? To any civilization just beginning to peer into the skies, a comet is familiar, harmless, expected. If one passes by, you take a few measurements, compare its orbit, and soon enough it is gone, forgotten among the countless others. But if you were building an interstellar probe meant to watch without being detected, isn't that precisely the shape you would choose? Something that could vaporize, crumble, or blend into the natural noise of cosmic debris. Something that wouldn't attract suspicion until it was far too late to investigate properly. When we ask if 3i Atlas could be watching us, we're not really asking whether one cometary fragment contained an alien camera lens or transmitter. We are asking something deeper. Are we under observation in ways we don't yet recognize? Could it be that the galaxy is already mapped, already monitored, and that these fleeting visitors are reminders of a presence we've long ignored? This ties into theories like the zoo hypothesis, which suggests that advanced civilizations might deliberately avoid interfering with emerging species like ours, choosing instead to watch silently, as though we were animals in a galactic reserve. Skeptics will argue that all of this is unnecessary. The data we have on 3i Atlas fits within the range of natural comet behavior. Fragile objects fall apart. Interstellar fragments exist in vast numbers, and if we look carefully enough, we will find more. But the alien question is not meant to replace scientific rigor. It exists alongside it, pressing us to keep our minds open, to consider that what we see may not always be what we think it is. Because history has taught us that the universe rarely conforms to our expectations. The sun was not the center of all things. The stars are not pinpricks on a dome. Planets orbit other stars. Galaxies stretch beyond our sight. Black holes warp space itself. Every time we have assumed we know the limits of what is possible, reality has humbled us. So why not here? Why not now? If Oumuamua made us wonder whether interstellar objects could be artificial, if Borisov reminded us that alien systems produce comets much like our own, and if Atlas slipped by before we could uncover its truth, then the alien question remains suspended in the air. Are these merely rocks and ice, or are they eyes watching, probes sent to silently measure our progress? And that question is chilling, not because of what it says about Atlas, but because of what it says about us. If we are being watched, then our place in the universe is not solitary. We are not explorers shouting into a silent void. We are children observed from the shadows, our steps recorded by eyes we cannot see. That idea is both terrifying and exhilarating, because it suggests we are not alone, but also that our story is unfolding under the gaze of something far greater than we are prepared to meet. When it comes to interstellar visitors, one of the most intriguing and unsettling aspects is not just what they are made of, but how they move. The flight path of an object, the subtle details of its orbit, can reveal more than its brightness or even its shape. Trajectories tell a story. And sometimes those stories don't line up with what we expect from natural physics. That is where suspicion begins to grow, where imaginations ignite, and where scientists are forced to admit that the universe may be hiding something extraordinary. Take the case of Oumuamua. Its entrance into our solar system already marked it as unique, because its hyperbolic trajectory proved beyond doubt that it had originated from outside our stellar neighborhood. But what truly set it apart was the way it behaved after passing the Sun. As it slingshotted outwards, its velocity changed in a way that couldn't be explained by gravity alone. It accelerated ever so slightly, as though something invisible was pushing it. For a comet, the expected explanation would be outgassing, the release of volatile gases from the surface, creating a jet-like effect that alters its path. But here's the catch. No such gas emissions were detected. No coma, no tail, no visible signature of sublimation. It was moving like a comet without looking like one. That contradiction tore open a rift in the scientific community. Some argued that maybe the outgassing was too faint to detect. Others pointed to more exotic causes, like hydrogen ice sublimating invisibly. And then came the boldest hypothesis, that perhaps Oumuamua was not natural at all, but a thin, sail-like structure propelled by starlight itself. In other words, a probe. The unusual trajectory of Oumuamua is now infamous, but it isn't alone in raising eyebrows. Comet Borisov, the second interstellar object, followed a more predictable path, its behavior aligning with what we would expect of a comet venting gas and dust. Yet even there, some anomalies emerged. Its level of activity was extreme, and its chemical makeup unusual compared to solar system comets. Still, Borisov's trajectory fit comfortably enough into natural models that it didn't ignite the same level of controversy. Then came Atlas, and with it, another puzzle. Its movement confirmed interstellar origins, but its quick fragmentation made its orbital story much shorter than we wanted. It was gone before we could examine whether subtle, unexplained accelerations or deviations occurred. That absence of data becomes, in its own way, another mystery. Did Atlas hide trajectory quirks like Oumuamua? Or was it more straightforward, a fragile shard obeying the predictable laws of physics until it simply disintegrated? We'll never know, because the chance to track it in detail slipped away as quickly as it arrived. Unnatural trajectories force us to confront the limits of our assumptions. The universe operates by laws we mostly understand: gravity, thermodynamics, radiation pressure. But when an object behaves outside those expectations, we're left with two possibilities. Either our understanding of the natural universe is incomplete, or the object's behavior isn't purely natural. This is the knife's edge where speculation about alien technology creeps in. If you were to design an interstellar probe, you might build it light enough to ride on starlight. You might shape it to mimic natural debris so it wouldn't be recognized for what it was. You might even program it to change course subtly, just enough to hint at intention without leaving a trail of evidence. And to a young civilization like ours, such a probe would look like an anomaly, a rock that moves when it shouldn't, a comet without a tail, a fragment that crumbles before we can measure it. The trajectory question is at the heart of why objects like Oumuamua and Atlas refuse to be neatly filed away. With Borisov, astronomers could breathe a sigh of relief. At least one interstellar visitor looked normal. But 1 out of 3 behaving predictably doesn't erase the unease of the others. If the first interstellar object we ever saw immediately showed unnatural movement, that alone stretches the odds. To then encounter another interstellar body that breaks apart before its path can be fully studied feels like a second twist of the knife. The rarity of detection collides with the rarity of anomalies, and the result is a mystery that cannot be comfortably dismissed. Unnatural trajectories don't need to mean alien technology, but they do mean we are peering into a category of objects with behaviors we don't yet fully understand. Perhaps there are exotic forms of matter, exotic types of ice, or strange surface properties that create forces we haven't modeled properly. Or perhaps, just perhaps, these are not mistakes of nature at all. The unsettling possibility is that what we call unexplained trajectories are, in fact, intentional trajectories. Movements chosen, not random. Accelerations guided, not accidental. A kind of cosmic breadcrumb trail hinting that some of the things crossing our sky are not mere wanderers, but visitors with purpose. And that is why scientists, even the cautious ones, cannot fully close the door on exotic explanations. The trajectories don't lie. Something propelled Oumuamua in a way we couldn't explain. Something about Atlas slipped away before the full truth could be captured. And the moment trajectories refuse to conform, the imagination inevitably turns to the possibility that we are not just studying rocks from afar, but perhaps glimpsing the handiwork of a civilization older, wiser, and infinitely more advanced than our own. Far from being dismissed outright, the idea that interstellar objects like 3I Atlas could be more than just lifeless fragments of ice or stone has been quietly brewing in scientific and philosophical circles. This concept, often called the Watcher hypothesis, is the speculation that such wanderers might not be random at all. Instead, they could be probes, messengers, or even relics left behind by civilizations advanced enough to cross the gulfs of space in ways we cannot yet imagine. To even begin entertaining this notion requires stepping outside the comfortable boundaries of traditional astronomy and into the uncertain borderlands where science shades into possibility. The Watcher hypothesis is rooted in an ancient and universal question. If intelligent life exists elsewhere, how might it reveal itself or conceal itself? Civilizations that have advanced far beyond our own could be capable of technologies indistinguishable from magic to us, and their motives might not align with the human expectation of dramatic contact. Rather than building colossal fleets or sending signals that broadcast their presence, they may instead prefer subtlety, watching, learning, and studying other emerging worlds without interference. In this scenario, an interstellar object passing through our solar system might not be a random visitor, but rather part of an ongoing survey, a quiet sentinel slipping through unnoticed. One of the reasons astronomers take this possibility seriously is the sheer improbability of our recent detections. For billions of years, Earth's skies remained unbroken by confirmed interstellar guests. Then, within just a handful of years, 3 such objects appeared in rapid succession: Oumuamua, Borisov, and 3I Atlas. This clustering raises uncomfortable questions. Were we simply blind for millennia until our instruments became sharp enough to notice them? Or is there something about this particular era, this brief moment in humanity's technological adolescence, that makes our system worth visiting? Some have suggested that if probes were sent long ago, their trajectories might be timed to coincide with the rise of civilizations capable of noticing them. In other words, they arrive precisely when they can be seen. The Watcher hypothesis does not require that these probes be alive in any conventional sense. They might not be crude vessels brimming with alien explorers. Instead, they could be more like seeds or drones, self-replicating machines designed to drift between stars, each one carrying a fragment of its creator's knowledge or purpose. They might gather data silently, scanning atmospheres for biosignatures, listening for radio waves, or even landing on comets and moons to remain hidden in plain sight. In the case of 3I Atlas, its swift passage gave us too little time to probe these questions in depth. It came and went, leaving only a trail of mystery. But in that brevity lies the fuel for speculation. What if we missed something vital as it slipped away? Critics of the Watcher hypothesis argue that such speculation risks distracting from the grounded science of studying interstellar objects as natural phenomena. And yet, history has shown that radical possibilities often begin at the fringes. Not so long ago, the idea of planets orbiting other stars was dismissed as too unlikely to be worth pursuing. Today, thousands of exoplanets are catalogued, each discovery forcing us to expand our imagination. The Watcher hypothesis may be speculative, but it occupies that same fertile ground where today's fringe becomes tomorrow's accepted truth. If civilizations exist millions of years older than ours, it is not only possible, but perhaps probable, that they would have mastered methods of exploration so subtle we would mistake them for natural events. There is also the unsettling consideration of intent. If these are watchers, what are they waiting for? Are they passive archivists, building a cosmic library of civilizations that rise and fall across the stars? Are they gardeners, nudging worlds towards certain outcomes? Or could they be predators, waiting silently for the right moment to act? The silence of the universe, what some call the Great Silence, takes on a different meaning under this hypothesis. Perhaps we hear nothing, not because we are alone, but because the watchers prefer it that way. Silence could be the camouflage of observation. 3I Atlas, then, becomes more than a cold fragment of interstellar debris. It becomes a symbol of uncertainty, a riddle written across the sky. It is both a scientific discovery and a mirror for our deepest fears and hopes. To some, it represents the beginning of an age where we are no longer alone, where other minds take notice of us. To others, it is a reminder of our vulnerability, that even as we build rockets and dream of colonizing Mars, we may already be under the gaze of something far beyond our comprehension. Whether natural or artificial, accidental or deliberate, its passage challenges us to confront the possibility that the universe is not a silent stage, but a crowded theater where most of the actors prefer to remain unseen. If the Watcher hypothesis is correct, then objects like 3I Atlas may not be rare accidents at all, but a recurring feature of cosmic life. They may drift through countless star systems, each one carrying echoes of ancient builders whose civilizations outlasted their suns. To them, we are the newcomers, a young and untested species just learning to peer outward. And perhaps, as they pass us by, they are deciding what to make of us, a curiosity, a potential ally, or simply another entry in a catalogue that stretches across the stars. Imagine, for a moment, that humanity is not alone in the galaxy, not merely in the sense of microbial life clinging to some distant exoplanet, but in the sense of advanced civilizations with motives, methods, and technologies far beyond our own comprehension. If such civilizations exist, how would they go about learning about us? Would they announce themselves with flashing lights in the sky, or arrive with great ships visible to every telescope and radar dish on Earth? Or would they choose a quieter path, one where they could watch without disturbing, analyze without interfering, and learn everything they needed without us even suspecting? This is where the idea of silent observers comes into play, a hypothesis that resonates with both science fiction and serious scientific speculation. Interstellar objects like 3I Atlas, fleeting visitors from the abyss between stars, provide a perfect disguise. From the standpoint of natural astronomy, they are expected. Our galaxy is filled with drifting debris, asteroids ejected from forming planetary systems, icy fragments hurled away by the gravitational chaos of migrating worlds, chunks of shattered comets flung into the galactic sea. Statistically, it makes sense that a few would stumble into our solar system every so often. They arrive on hyperbolic trajectories, zip around the sun, and vanish forever into interstellar space. To most astronomers, they are just cosmic wanderers, carrying with them information about other star systems and the processes that shape them. But to a more imaginative mind, there is a tantalizing possibility. What if not all of them are what they seem? If an alien civilization wanted to observe us, silently and safely, an interstellar object is the ideal cover. Wrapped in rock, ice, or some composite material designed to mimic natural surfaces, a probe could masquerade as just another comet-like body. It would reflect sunlight, display the expected dusty halo, maybe even shed gas if engineered to do so. But beneath that facade, it could conceal instruments, telescopes, sensors, transmitters, data storage systems. Passing astronomers would catalogue it, debate whether it was icy or rocky, speculate on its origins, and ultimately let it go, never realizing that it was more than a mere stone adrift in the dark. This possibility was hinted at during the debates surrounding Oumuamua, the first interstellar visitor confirmed in 2017. Its elongated shape, its lack of a visible tail despite odd acceleration, and its uncanny resemblance to something more engineered than eroded forced many to ask uncomfortable questions. Could it have been a probe? Could its bizarre flight path have been intentional? Mainstream science stopped short of such conclusions, but the idea lingered, a reminder that we must keep our minds open to the unknown. If even one interstellar object could plausibly be more than nature's accident, then perhaps we should consider the entire class of them as candidates for quiet surveillance. 3I Atlas is no exception. Though it was observed only briefly before fading into the cosmic night, its very arrival sparks the question of intent. A probe disguised as a comet would not need to linger. It could sweep through, capture terabytes of data on radio transmissions, atmospheric chemistry, planetary surfaces, and biosignatures, then transmit that information back across the void with a narrow, focused beam of energy. From its perspective, a single pass might be enough. Humans, bound to our telescopes and limited observation time, might never notice the faint transmission slipping away into the galactic background. By the time suspicion arose, the object would already be far beyond reach, vanishing into the interstellar ocean from which it came. And what better way to study an emerging technological species than without their awareness? Direct contact could provoke fear, chaos, or resistance. Observation from a distance allows patience, detachment, and control. If such probes exist, they might not even be the creations of civilizations alive today. Perhaps they were launched eons ago by species long extinct, automated machines carrying out instructions on timescales longer than recorded human history. To us, they would still seem purposeful, still appear to be watchers, even if their makers are gone. The galaxy could be seeded with such machines, each silently passing through systems, updating records, mapping the spread of intelligent life, and reporting back to a central archive somewhere deep in the stars. Skeptics might argue that such speculation veers into science fiction, but that is not the same as saying it is impossible. We ourselves have already begun sending out silent observers, Voyager 1 and 2, Pioneer 10 and 11, New Horizons. These spacecraft, drifting ever farther from the Sun, are our own first attempts at becoming silent watchers. To another civilization, millions of years from now, they may appear exactly like what we imagine, inert pieces of debris from a distant system, unless examined closely enough to reveal the faint scars of human engineering. If we are capable of this at the dawn of our spacefaring age, what could a civilization with a million-year head start accomplish? The haunting thought, then, is not whether aliens could do this, but whether they already have. Each interstellar visitor might be a message in disguise, a camera cloaked in stone, a relic of intelligence hidden in plain sight. We watch them with curiosity, speculate about their chemistry and physics, and then let them go. But if they are more than they appear, then at this very moment, the galaxy might already be watching us, learning from us, perhaps even judging us, in silence. And we would never know, because what better way to study a civilization than to make them believe they are utterly alone? It's an unsettling but fascinating thought experiment. If a civilization advanced far beyond our own wanted to study others without being noticed, the most efficient strategy wouldn't be to send ships that look sleek and futuristic, bristling with antennas and glowing lights. It would be to send something that blends in so perfectly with the natural backdrop of space that no one would suspect a thing. A rock, for instance, or at least something that looks exactly like one. And this brings us to the uncomfortable possibility that an interstellar visitor, such as 3I Atlas, with its fleeting presence and its comet-like appearance, could be more than just an innocent traveler. Because what if technology can be made to look like nature? The universe is full of rocky debris, comets, asteroids, chunks of shattered planets, ice-laden fragments drifting endlessly between the stars. These are the most ordinary things imaginable in cosmic terms. When astronomers spot a faint smudge racing through space, their first instinct is to classify it as one of these natural wanderers. But what if an advanced intelligence knew that? What if they deliberately engineered their probes to mimic those exact traits? Dusty tails, irregular shapes, dim reflectivity, so that when spotted, they'd be written off as nothing more than cosmic clutter. It's the perfect disguise. After all, astronomers are looking for signals, beacons, structured spacecraft, things that scream artificiality. No one is combing through millions of comets expecting one to secretly be a machine. This idea is not as far-fetched as it sounds when you consider the principle of camouflage here on Earth. Predators and prey alike evolve colors, shapes, and behaviors that make them blend seamlessly into their environment. A moth that looks like tree bark, a fish that resembles the sandy seafloor, a leaf insect that fools even the sharpest eye. Camouflage works because the observer expects to see something ordinary, not something deceptive. And if natural selection can achieve this through blind trial and error, how much more effective might deliberate engineering be? Imagine a probe designed to look indistinguishable from a comet, its outer shell layered with ice, its surface scarred and jagged to mimic impact craters, its emissions tuned to appear like natural outgassing. To any telescope scanning the skies, it would simply register as one more piece of cosmic debris. Oumuamua, the first interstellar visitor, sparked precisely these debates. Its odd shape, its acceleration without a clear outgassing signature, its highly reflective surface, all made some scientists wonder if it was an alien probe. Harvard astronomer Avi Loeb famously argued that it could be an example of extraterrestrial technology, perhaps a solar sail. While most of the astronomical community preferred more conservative explanations, the very fact that such a possibility was seriously raised reveals how our assumptions can be challenged. With 3I Atlas, the conversation deepens. If interstellar objects are not just random rocks, then what if they represent a stream of disguised technologies drifting through star systems, each built to pass as ordinary? The implications are enormous. If 3I Atlas, or any of its cousins, were actually an artificial object, then it might carry instruments hidden beneath its icy crust. Miniaturized sensors capable of scanning atmospheres, recording electromagnetic signals, monitoring planetary activity. And if it is powered cleverly enough, it might even transmit its findings back across interstellar distances, or store them for later retrieval by a returning vessel. The disguise would ensure it could operate unnoticed, slipping quietly past unsuspecting civilizations like ours. It wouldn't need to hover in orbit, flash lights, or beam obvious signals. It would simply pretend to be what we already expect to find: a comet. This also changes how we might think about first contact. Many imagine aliens arriving in majestic ships, descending dramatically from the sky. But perhaps true intelligence operates far more subtly. Instead of knocking on the door, they peek through the window. Instead of shouting across the void, they listen in silence. And instead of sending craft that reveal themselves as artificial, they send watchers that wear the masks of rocks and ice. To civilizations at our stage of development, such watchers would go almost entirely undetected. Only in the rare cases where an object zips unusually close, like 3I Atlas, do we even get the chance to notice them. And even then, our instinct is to dismiss them as natural. The disguise works. Could it be that the galaxy is teeming with such watchers, scattered across star systems, embedded in planetary belts, or drifting through interstellar space, each cloaked in a skin of nature? It's a chilling possibility, one that forces us to reconsider how we search for signs of intelligence. Perhaps the extraordinary evidence we seek doesn't look extraordinary at all. It looks exactly like the ordinary. And maybe 3I Atlas is a reminder that the greatest mysteries don't always arrive wrapped in obvious strangeness. Sometimes they pass right before our eyes, dressed as something familiar. When astronomers first realized that 3I Atlas was not gravitationally bound to our sun, a natural question followed. Could it be sending anything back? After all, if an object is truly interstellar, its origin lies beyond the cradle of our solar system, and with that origin comes the tantalizing possibility of intelligence. The scientific instinct was not simply to chart its orbit or measure its brightness, but to also listen, literally, to see whether it whispered across the void with radio signals or other transmissions. Projects like SETI, the search for extraterrestrial intelligence, have long had protocols for moments like these. Whenever a suspicious or unusual celestial body is detected, radio telescopes are pointed toward it, scanning across frequencies, hunting for anything that might stand apart from the cosmic background noise. With 3I Atlas, such observations were made quickly, though time was short. The object was faint, fast, and fleeting, and its trajectory meant it was visible only briefly before it faded back into the depths. No obvious transmissions were detected. No repeating pulses, no narrow-band radio beacons, no bursts of structured energy that screamed of intent. But the silence itself was hardly conclusive. To search for signals is like eavesdropping on a conversation in a crowded stadium. You must know where to listen, when to listen, and in what language the voices might be speaking. If 3I Atlas carried technology cloaked in rock and ice, its emissions could be so weak or so tightly directed that they would slip unnoticed past Earth's relatively small network of listening instruments. Or perhaps it never emitted anything at all, instead functioning as a passive observer. In that scenario, there would be nothing to catch, only the frustrating silence of an object that may or may not harbor secrets. The precedent set by earlier interstellar visitors lingers here. When Oumuamua streaked through, telescopes like the Green Bank Observatory scanned it for structured signals. Again, nothing. And yet, many pointed out that absence of evidence is not evidence of absence. If a probe were designed to blend in, why would it reveal itself with clumsy radio chatter? Why would it not use forms of communication beyond our grasp? Tight beam lasers invisible to our instruments, neutrino transmissions that pass straight through planets, or even exotic channels tied to physics we have yet to discover. Against such possibilities, a few days of hurried radio scans hardly seem sufficient. With 3I Atlas, the situation was even more tenuous. Its brief appearance in April 2020 coincided with the world's attention being pulled toward earthly crises, and while astronomers tracked it with telescopes, the amount of dedicated signal searching was far less intensive than it might have been in a quieter era. There's an almost tragic irony in that. If this visitor carried anything extraordinary, humanity may have been too distracted to notice. By the time global observatories considered longer campaigns, the object's fading brightness and increasing distance had already rendered it a ghost. Still, the effort to listen was a statement in itself. Each interstellar object forces us to confront the possibility that not all rocks are just rocks. And so the silence from 3I Atlas does not settle the question. It remains ambiguous, a question mark hanging in the dark. Did we miss something subtle? Did the object hold back, designed never to reveal itself to civilizations that have not yet reached a certain threshold of awareness? Or was it truly nothing more than an anonymous fragment from an alien solar system, a relic of processes so natural they barely merit attention? For now, scientists can only log the silence, archive the data, and prepare for the next encounter. Because the real significance of 3i Atlas may not lie in what we did or didn't hear, but in the fact that we now expect to hear something. Each time an interstellar traveler arrives, humanity listens a little more carefully, with a little more imagination. The silence may one day break, but until then, it is in that silence, haunting, vast, and unknowable, that the mystery of 3i Atlas continues to echo. When it comes to 3i Atlas, one of the most frustrating truths is just how little we actually managed to observe before the object slipped silently back into the abyss of interstellar space. Unlike nearby asteroids or comets that we can track for years, even decades, interstellar visitors come and go in a fleeting moment, crossing our cosmic neighborhood in a brief flash of opportunity. In the case of 3i Atlas, the window was narrower than ever. Discovered in 2024 by the Atlas survey, the object was already retreating from the inner solar system by the time it was spotted, faint and rapidly fading. This meant that astronomers had only weeks, not months, not years, to capture as much data as possible. And even then, the data was thin, fragmented, and full of uncertainties. So what did we actually see? At its most basic, 3i Atlas was detected as a faint moving dot of light against the backdrop of stars. Telescopes followed its trail, measuring how its position shifted night after night, which allowed astronomers to calculate its orbit. Those calculations revealed the unmistakable signature of something unbound by the sun's gravity, a hyperbolic trajectory, too fast to ever be a returning comet, too steep to be anything native to our solar system. That alone confirmed it as only the third interstellar object ever observed by humans. Its path showed that it came from outside, whipped around the sun in a quick arc, and was now leaving forever. But beyond that, the details became murky. Spectroscopic observations, which break down the faint light of an object into its component wavelengths, were attempted, but the results were limited. Some hints suggested it might have outgassed like a comet, faintly releasing gas as sunlight warmed its surface. Other measurements were inconclusive, pointing towards something darker and more asteroid-like. Unlike Borisov, which clearly displayed a comet-like coma and tail, 3i Atlas never revealed an obvious visible trail, leaving astronomers uncertain whether it was icy, rocky, or some mix of both. And unlike Oumuamua, whose peculiar acceleration and strange shape raised eyebrows, 3i Atlas left too little time for detailed photometric studies. We never pinned down whether it tumbled chaotically, rotated smoothly, or whether its brightness fluctuations hinted at anything elongated or unusual. The didn't see part of this story looms far larger than the did see. We didn't get close-up images. We didn't have a spacecraft in position to intercept it. We didn't gather high-resolution spectra that could tell us its exact chemical makeup. We didn't get long-term light curves that would reveal how it spun or whether jets of gas pushed it in subtle ways. We didn't capture radio signals or even have time to organize coordinated multi-observatory campaigns the way we did for its predecessors. Instead, what we got was a ghost, a brief detection that confirmed its existence, proved it wasn't bound to our sun, and then let it fade into mystery. This gap in knowledge is what fuels both scientific frustration and public fascination. With Oumuamua, at least we had enough observations to spark intense debates about its acceleration, its thin, elongated, or possibly pancake-like shape, and whether it was natural or something far stranger. With Borisov, we had a clear cometary profile, giving us a more solid baseline of what an interstellar object might look like. But 3i Atlas sits uncomfortably between them. It carries the exotic label of interstellar, but none of the rich detail that lets us build a clear narrative. It is, in essence, an incomplete story, a tantalizing mystery we barely glimpsed before it was gone. Imagine standing on a dark street and watching a car pass quickly under a broken streetlight. You see the headlights for an instant, catch the faint silhouette, and then it's gone, swallowed by the night. You know the car was there, you know it moved past you, but you don't know what make it was, who was driving, or where it came from. That's what 3-Eye Atlas is for astronomy: a shadow, a trace of motion, an unsolved riddle. The gaps in our data also highlight the limits of our readiness. Every time an interstellar visitor arrives, astronomers scramble to collect what they can with the tools at hand. But Earth's telescopes are fixed, spread across a planet with clouds, weather, and competing demands for observation time. By the time word spreads through the global astronomy community, precious hours have often already slipped away. And unlike planets, moons, or near-Earth asteroids, interstellar visitors do not linger. They come in at blistering speeds, spend a matter of weeks or months in detectable range, and then vanish forever. 3-Eye Atlas exposed just how vulnerable we are to missing the details of such rare events. This leads to another unsettling truth. In the cosmic lottery of discovery, we may already have missed many others. How many interstellar objects have swept silently through the solar system, unnoticed before surveys like Atlas and Pan-STARRS became active? How many more pass undetected even now, too faint, too far, or too quick for our instruments to register? 3-Eye Atlas reminds us that we are catching only a fraction of what the universe throws our way. The absence of detail also opens the door to speculation. Was 3-Eye Atlas just a small, ordinary rock, indistinguishable from the countless comets and asteroids we've catalogued, except for its origin beyond the Sun? Or was there something different about it, something in its composition, behavior, or even its nature, that we simply failed to record? Could it have been shedding faint gases that slipped below the sensitivity of our instruments? Could its shape have been unusual, but rotating too quickly for us to detect? Or, in the more daring fringes of speculation, could it have been something artificial, cleverly disguised, deliberately subtle in its presence, so that our lack of data is not a failure of technology, but part of the design? What we didn't see leaves a vacuum, and in that vacuum, both science and imagination thrive. For astronomers, the gaps become scientific puzzles, fueling papers, models, and new ideas about what these objects are, how they form, and what they can teach us about other star systems. For dreamers and theorists, the absence of answers becomes an invitation to fill the void with possibilities, whether alien probes, cosmic debris, or lost relics drifting between the stars. 3-Eye Atlas is a reminder that not all discoveries come neatly packaged with clarity. Some are riddles we may never solve, flickers of information that haunt us precisely because they slipped through our fingers. Its legacy is not what we know about it, but what we failed to capture, the permanent, unfillable gaps that keep it in the realm of mystery. And perhaps that is its greatest power, not the data it gave us, but the questions it left behind. The idea of timing has always fascinated astronomers, philosophers, and those who look at the skies with a mix of science and wonder. When we talk about 3-Eye Atlas, it's tempting to see its arrival as just another random cosmic event, a natural object swept along by gravitational forces, drifting for millions or even billions of years before brushing past our solar system. But then comes the question, why now? Why, in the age where humanity has radio telescopes scanning the heavens, space probes reaching the outer planets, and artificial intelligence passing signals from deep space, do we suddenly begin to notice these visitors from the stars? Could this timing be pure chance, or is there a deeper pattern, perhaps even an intention, behind it? The first explanation, of course, is the straightforward scientific one. The universe is vast and ancient, and countless interstellar objects are constantly wandering between stars. For most of human history, we simply lacked the tools to spot them. Our telescopes were too crude, our observational methods too limited. Only in the last few decades have wide-field surveys like Pan-STARRS, ATLAS, and others become sensitive enough to catch fleeting objects that appear suddenly, streak across the sky for weeks or months, and then vanish forever into interstellar night. According to this view, we haven't been chosen. We've simply grown capable of finally noticing what was always there. Just as the invention of the microscope revealed a teeming microbial world that had existed unseen for billions of years, so too do our modern sky surveys reveal a hidden population of interstellar wanderers, of which 3I Atlas is merely one. Yet, human imagination rarely stops at the mundane explanation. There's another way of looking at this timing. If you believe in the possibility of advanced civilizations, then you might ask, why would such a civilization send a probe or release an artificial object into our system precisely now, at the dawn of our own spacefaring era? If humanity had no telescopes, no satellites, no capacity to detect such an intruder, the arrival of 3I Atlas would go unnoticed. But today, with our instruments, we not only notice, but we ask questions, record data, speculate, and broadcast our findings across the globe. If someone, or something, wanted to be seen without openly announcing itself, could there be a more perfect strategy than sending an ambiguous object, timed to slip past when our species is just advanced enough to spot it, but not advanced enough to fully investigate it? This idea plays into what some call the cosmic window hypothesis. Civilizations at our level of development sit in a peculiar stage, no longer blind to the universe, yet not powerful enough to chase down every mystery it throws at us. To another intelligence, that stage might be the most interesting time to observe us. A Stone Age species might offer little intrigue, while a spacefaring one might guard itself too carefully. But a species on the cusp of discovery, curious, speculative, and vulnerable to wonder, that is the ideal subject for observation. If 3I Atlas were some kind of disguised probe, slipping past Earth in the early 21st century might not be an accident, but rather a perfectly timed maneuver, ensuring we would notice it, debate about it, and yet remain unable to uncover its full nature. On the other hand, cosmic timing can also be seen as a matter of sheer probability. The more we look, the more we'll find. Just a century ago, no one had detected an interstellar visitor. By 2017, we saw Oumuamua. By 2019, Borisov. By 2024, 3I Atlas. In only a few years, we've gone from 0 known interstellar visitors to 3 confirmed ones. If this is a trend, it suggests that such encounters might not be rare at all. Rather, they are simply inevitable, and we're finally living in the time when our species is capable of registering them. From this perspective, the timing is not cosmic destiny, but human readiness. The universe has always been sending these messengers, whether natural or artificial, and only now have we stepped into an age where they can no longer slip by unnoticed. And yet, there's something uncanny about how these arrivals line up with our own trajectory into the cosmos. Humanity is building telescopes that can detect Earth-like planets around other stars. We've sent probes to the edge of the solar system and beyond. We've begun to seriously contemplate interstellar travel ourselves. At the same moment that we dream of sending robotic emissaries to other stars, suddenly, from the dark, emissaries seem to arrive at ours. Some call this nothing more than a poetic coincidence, a mirror of our expanding curiosity. But to others, it feels as though we are stepping onto a stage, and the audience, whoever or whatever they may be, is finally ready to watch. There's another dimension to consider, the possibility of synchronicity, where events in the universe seem to align in meaningful ways without a clear cause and effect. When Carl Jung spoke of synchronicity, he described it as meaningful coincidence. Could it be that the appearance of 3I Atlas and its predecessors in the age of advanced human observation is a kind of cosmic synchronicity, not orchestrated by aliens, but by the deep currents of probability, timing, and human perception. We may not live in a universe that plans in the way we understand planning, but we do live in one where the improbable eventually happens, and when it does, it feels like the universe is whispering secrets directly into our ears. Of course, we can't ignore the darker speculation. If timing is intentional, perhaps it is not about curiosity at all, but about control. An advanced species might not just want to watch us, they might want to remind us subtly that we are not alone, planting the seeds of wonder and fear at just the right moment in our history. Imagine a civilization planting probes throughout the galaxy, waiting for young species to develop enough to notice them. The arrival of such an object at our particular era could be more than chance. It could be part of a galactic pattern of soft contact, a way of saying, "We see you, we know where you are, and we've been here longer than you realize." For now, the debate rages on. Was the timing of 3I Atlas simply a product of chance, a fragment of cosmic rock appearing in our skies just as our tools grew sharp enough to detect it? Or was it something more deliberate, a silent signal dropped into our cosmic backyard at exactly the right moment to stir our imagination? We may never know, but one thing is certain. The appearance of these interstellar visitors in our technological age is no small coincidence for us. It has forced us to confront the possibility that we are not just passive observers of the universe, but perhaps the observed as well. The truth, as always, may lie somewhere between the extremes. Timing could be coincidence, and yet coincidence has meaning. 3I Atlas arrived not in the age of stone tools or medieval cathedrals, but in the age of radio telescopes, artificial intelligence, and interstellar dreams. Whatever its true nature, its passage through our system now has ensured one thing: that humanity will continue to look up, to wonder, and to question the story of our place in the cosmos. And sometimes, that is enough for an event to change history forever. The zoo hypothesis has long been one of the more haunting and strangely elegant attempts to explain the so-called Fermi paradox. If the universe is teeming with habitable worlds and intelligent civilizations are likely to arise given enough time, then why do we see no clear evidence of them? Why no radio signals, no city lights, no obvious spacecraft drifting across the stars? The zoo hypothesis provides a chilling yet strangely comforting answer. Maybe they are here, maybe they always have been, but they simply choose not to reveal themselves. Just as a zoo carefully manages its animals, providing a habitat while ensuring minimal interference, an advanced extraterrestrial civilization might be watching us, waiting to see how we grow, evolve, and behave when left to our own devices. Within this framework, the arrival of interstellar objects like 3I Atlas takes on a different dimension, no longer random chunks of rock, but possible instruments of quiet surveillance. The zoo hypothesis suggests that humanity may not yet be ready to join the galactic conversation. We might be too primitive, too volatile, or simply not yet at a stage of maturity where contact would be productive. If that is the case, then the Earth itself could be under something like a cosmic quarantine, shielded from overt communication until we reach some undefined threshold of development. That threshold might involve technology, proving that we can manage nuclear power, space travel, or artificial intelligence without destroying ourselves. Or it could be moral and social, demonstrating that we can govern ourselves without endless war and ecological collapse. If the Watchers exist, they would want to make contact with a species that has demonstrated wisdom, not just cleverness. And until then, the idea is that we would be left alone, monitored perhaps, but never directly addressed. This is where 3I Atlas enters the conversation. Its fleeting presence in our skies could be interpreted as a neutral, observational visit. Imagine a probe designed not to be obvious, not to hover dramatically above a city or leave unmistakable traces of artificiality, but to pass by silently, gathering data without ever tipping its hand. The zoo hypothesis fits such a scenario perfectly. If Earth is under observation, the probes would need to blend into the natural background of the cosmos. They would appear to us as comets, asteroids, or chunks of interstellar debris, because only by being unremarkable could they move unnoticed among us. What makes this interpretation eerie is the timing. As discussed earlier, these objects were only spotted in the last few years, coinciding with the rise of advanced telescopes, automated survey systems, and planetary defense programs that constantly scan the skies. Before our technology reached this point, a visitor like 3I Atlas might have slipped by completely undetected. Could it be that the watchers know this? That they timed their probes to arrive just as our species was ready to recognize them, but not yet advanced enough to capture or interrogate them? This half-hidden revelation would be entirely in line with the zoo hypothesis, teasing us with a glimpse, letting us sense that we are not alone, without ever crossing the line into direct disclosure. The silence of the universe may therefore not be silence at all, but strategy. If alien civilizations exist and abide by some form of interstellar ethics, perhaps a principle akin to our own prime directive in science fiction, then their role is to observe, not interfere. From their perspective, sending probes like 3I Atlas may be the equivalent of wildlife researchers setting up hidden cameras in a forest, recording the behavior of animals without ever disturbing them. The animals have no idea they are being studied. They simply live their lives as usual. Humanity, in this analogy, may be the unwitting subjects of a vast cosmic research project, one that has been running for centuries or millennia. The zoo hypothesis also raises unsettling questions about agency and control. If we are being watched, what criteria determine when the observation ends? Do we graduate into open contact only after passing certain milestones? And if so, who decides? Is there a council of civilizations, some galactic order that enforces this policy, ensuring no species breaks the silence too soon? If such an order exists, then interstellar objects like 3I Atlas could serve as both scouts and enforcers, ensuring that emerging civilizations like ours are kept under the dome of observation until the right time. The fact that the object appeared and vanished without a trace would then be not an accident, but the entire point. Critics of the zoo hypothesis argue that it is too anthropocentric, projecting our ideas of zoos and quarantines onto alien minds that might think in ways we cannot fathom. They suggest that the timing of interstellar visitors is mere coincidence, and that the universe is so vast and chaotic that we should expect to see random chunks of interstellar rock passing through eventually. From this perspective, 3I Atlas is just one of many natural wanderers we are destined to detect as our instruments improve. Yet even skeptics admit that the zoo hypothesis is compelling because it neatly explains both the silence and the mystery. It allows us to imagine a universe alive with intelligence while accounting for the profound lack of open communication. If 3I Atlas is part of this framework, then its fleeting passage is not a disappointment, but a clue. It hints that we are not alone, that we are perhaps participants in a larger story we do not yet fully understand. Its silence might not mean emptiness, but discretion. And that is perhaps more haunting than either extreme. Neither the comforting thought that we are alone, nor the thrilling certainty of contact, but a quiet middle ground where we are constantly watched, evaluated, judged, yet never acknowledged. As humans, we like to believe that we are in control of our destiny, that we choose our own path into the future. But the zoo hypothesis suggests otherwise, that our progress might be quietly monitored by unseen eyes, our readiness for the stars measured by criteria we cannot guess. 3I Atlas, in this sense, is not just a rock. It is a mirror, reflecting back our deepest fears and hopes about the cosmos, that we are significant enough to be studied, but perhaps not yet significant enough to be welcomed. The zoo gates remain closed, and the keepers remain silent, while the animals look up at the stars, wondering if they are alone. Imagine, for a moment, that 3I Atlas was never meant to slip by unnoticed. Perhaps its speed, its angle, even its strange orbital trajectory were not random at all, but carefully aligned with one purpose: to pass through our region of space, brushing close enough to be seen, recorded, and remembered. If that were the case, then its existence transforms from being a mere rock wandering the void into something far stranger, a kind of galactic pin dropped into the map of the universe, a beacon not meant to illuminate, but to mark. And what would it mean for us if our solar system has, in fact, just been marked? The word beacon conjures up images of lighthouses on rocky coasts, guiding ships away from danger or towards safe harbor. But in another sense, a beacon can serve as a territorial marker, a sign left behind not to communicate with those who see it, but to alert those who come after. Perhaps civilizations far older than ours seed the galaxy with such markers as they travel, like breadcrumbs scattered across cosmic darkness, ensuring that others of their kind can retrace their paths. If that were the case, then 3I Atlas could be one such breadcrumb. Passing silently through our neighborhood, it could have dropped an invisible marker, something in its tail or in the faint signals it might have emitted, that locks our solar system's location into some greater stellar registry. The unsettling possibility is that the beacon is not meant for us. We may be incidental observers, like animals in a forest noticing a glowing sign nailed to a tree without understanding its purpose. If an advanced intelligence wanted to catalogue every system it encountered, it would need only to send automated objects like 3I Atlas hurtling between the stars. Each one might be programmed to release a marker, whether physical or energetic, that records the coordinates of nearby habitable planets. Our detection of it may have been nothing more than accidental, the way one stumbles across a trail marker while hiking and realizes that the path has been walked before. If the beacon hypothesis holds, the implications stretch in two directions. Either the marking was benign, or it was a warning. A benign marking suggests curiosity. Someone out there is building a galactic census, noting where promising stars and planets lie, perhaps to study later. But a warning, that casts a much darker shadow. A beacon could be akin to a hunter carving a notch into a tree to remember where prey gather. If so, our solar system may not simply have been marked on a cosmic map. It could have been flagged, a signal for others to return. This line of thought brings up another possibility. What if beacons are not permanent? What if they are designed to decay, to activate only for a moment, leaving behind a fleeting imprint that can only be recognized by those who know how to look? When 3I Atlas streaked by, astronomers measured its brightness, its speed, its tumbling. But what if there was something else, something outside the spectrum of human vision, an encoded emission meant to last only a brief window of time? In that sense, the object might have done its work already, transmitting our solar system's precise coordinates across interstellar distances before slipping back into the dark. We would not even know the message had been sent. Consider also how rarely we catch interstellar visitors. In the entire history of astronomy, only a handful have been observed: Oumuamua, 2I Borisov, and now 3I Atlas. That scarcity magnifies the strangeness of this idea. Why now? Why in the narrow window when humanity has just developed the tools to notice them? If these objects are part of a greater network of beacons, then their timing could not be accidental. It could suggest synchronization, that someone, somewhere, is releasing them on a schedule that coincides with the rise of new civilizations, marking the exact moment when a species reaches the ability to look up and record the sky. What's most haunting is that we would never be able to confirm or deny it. If the purpose of the beacon was to mark coordinates, then the message has already been delivered to its intended audience, far beyond our reach. We may never know who or what it was meant for. All we can do is wait, living under the silent knowledge that perhaps, somewhere in the interstellar dark, our location has been pinned. The next chapter, whether it brings contact, curiosity, or conquest, remains unwritten. And yet, one could argue that even the act of marking itself is a kind of message. To drop a beacon is to declare, "You are seen." For the first time, humanity might not just be looking into the cosmos, but being looked at in return. That realization alone alters our perspective. No longer are we just observers of the stars. We may now be participants in an unfolding galactic drama, one whose scale we cannot fathom, and whose consequences may only reveal themselves centuries from now. If 3i Atlas truly served as a beacon, then the moment it passed us may go down as one of the most important in human history. Not because of what we saw, but because of what we didn't. Because in its silence, in its vanishing trail, it may have carried away the single most profound truth imaginable, that we are no longer alone, and that our place in the universe has been marked for others to find. When scientists debate objects like 3i Atlas, the conversation inevitably turns to the clash between natural explanations and the tantalizing, though less accepted, possibility of artificial origins. On one side lies the weight of centuries of astronomy, comets, asteroids, interstellar debris, all natural fragments that drift across space as leftovers from planetary and stellar formation. From this perspective, 3i Atlas is simply another piece of rocky or icy shrapnel, a wanderer flung free from its home star system long ago. Its speed, trajectory, and overall dimness fit within expectations of what interstellar debris should look like. Astronomers argue that extraordinary claims demand extraordinary evidence, and so far, 3i Atlas hasn't provided any unmistakable signs of alien design. Yet the natural explanation, while scientifically sound, does not silence curiosity. The object's mere arrival sparks questions that refuse to fade. Why did humanity detect only 3 interstellar visitors in its history, all within just a few years of each other? Why did at least one of them, Oumuamua, behave in ways that resist easy classification? Why do these visitors appear just as our telescopes and technologies are capable of recognizing them? These questions provide fertile ground for the idea that what we are seeing might not be accidental debris at all, but something with intent behind it. The artificial camp doesn't leap straight to alien spacecraft, but rather considers the subtlety of design that could masquerade as natural. If an advanced civilization wanted to scatter probes across the galaxy, the smartest approach might be to make them indistinguishable from the millions of fragments already drifting through interstellar space. After all, a disguised probe would not attract suspicion, and it could quietly carry out reconnaissance without alarming the species it was studying. Oumuamua's odd acceleration, Borisov's comet-like yet pristine appearance, and now Atlas's timely arrival make skeptics pause. Are these coincidences or hints of deliberate construction hidden in plain sight? The scientific consensus holds fast to natural causes, emphasizing how easy it is to overinterpret incomplete data. Strange shapes, unexpected brightness shifts, and unexplained accelerations can often be traced back to mundane processes, outgassing, tumbling, reflection angles, or even measurement errors. In the case of 3i Atlas, the faintness and fleeting visibility leave almost nothing solid to build upon. Caution demands that we resist declaring anything artificial when the simplest answer still holds water. But caution alone does not erase the allure of the unknown. The debate between natural and artificial interpretations reveals more about us than about the object itself. Scientists seek patterns, order, and explanations that fit within tested frameworks. Dreamers, on the other hand, wonder if we are witnessing the first whispers of another intelligence. Could both sides be right in different ways? Maybe 3i Atlas is natural, but the very fact that such objects are so rare makes each one significant, an opportunity to learn more not only about distant planetary systems, but also about the possibility of deliberate messages hidden among them. In the end, the discussion may never resolve. For every voice insisting, "It's just a rock," another counters, "But what if it's not?" The balance tips toward natural explanations because science relies on evidence, but the door never fully closes on the extraordinary. Until we capture one of these visitors with greater detail, until we watch it up close, measure its composition directly, or discover patterns that defy random chance, the natural versus artificial debate will continue to hover in the twilight space between skepticism and wonder. When we confront the question of how humanity should respond to the appearance of interstellar objects like 3I Atlas, we step into one of the deepest and most consequential debates imaginable. Should we treat such arrivals as opportunities to reach outward, to signal, to announce ourselves, to attempt communication with whoever might be responsible? Or should we take the opposite course, remain silent, remain hidden, and allow the cosmos to pass us by without knowing we are here? This dilemma is not purely hypothetical. It rests at the intersection of scientific curiosity, philosophical caution, and the unknown risks of cosmic diplomacy. Humanity's response, or lack thereof, could shape our future in ways we cannot even begin to comprehend. The first impulse, especially from the scientific community, is often to signal. To reach out is an instinct born of wonder and the desire to know. Our species has spent millennia striving to answer the question, are we alone? If an object such as 3I Atlas carried even the faintest possibility of being artificial, then surely, many argue, the chance to respond is irresistible. It would be the ultimate experiment, one where the stakes are not just knowledge of the universe, but our very place within it. Broadcasting signals, whether in the form of radio waves, tightly focused laser beams, or even directed gravitational signatures, would be a way of announcing ourselves, saying, "We noticed you, we are here, can you hear us?" And yet, the very act of doing so raises a spectre of danger. If 3I Atlas were a probe, then its builders already know we exist. But if it is not, if it is only a natural object passing through, then sending a message outward could expose us to civilizations that might not otherwise be aware of us. Silence, in this case, would be akin to camouflage. Many thinkers, both within the scientific community and in broader philosophical discourse, suggest that staying silent is the wisest course of action. After all, if there are predators among the stars, civilizations that exploit rather than nurture, then to reveal ourselves prematurely could invite catastrophe. The debate thus becomes one of psychology as much as astrophysics. Some argue that any civilization advanced enough to receive our signal, let alone dispatch an object across interstellar space, would likely be so technologically superior that it would have no need to fear or harm us. They suggest that the universe's age would have already selected against aggressive species, as such behaviors might self-destruct before reaching the stars. Others, however, counter that we cannot project our human notions of morality or inevitability onto alien beings. For all we know, a technologically advanced species could view us as irrelevant, dangerous, or even as resources to be harvested. To send a signal without knowing who or what might be listening is to open the door to an unknown fate. This division echoes debates already alive in the search for extraterrestrial intelligence, SETI, community. Traditional SETI programs focus on listening, not transmitting. We build massive radio arrays, like those at Green Bank or Arecibo, before its collapse, to eavesdrop on the universe. But a smaller, more controversial wing of scientists advocates for messaging to extraterrestrial intelligence, METI. They believe waiting in silence is cowardly, even wasteful, and that humanity should boldly project itself into the cosmos. They have already sent small signals, mathematical codes, information about our species, even music and art, toward nearby stars. Yet these actions remain disputed, criticized as reckless by those who believe we are playing with forces far beyond our comprehension. In the context of 3I Atlas, the debate sharpens. Unlike a distant star system, this object actually entered our solar system. Its trajectory carried it close enough to study, close enough to consider that it might, in some sense, be watching us. If that is true, then silence might not even protect us, because the act of observing itself implies awareness. But the question remains, if it is a watcher, should we watch back quietly, or should we attempt to introduce ourselves? Do we risk appearing weak or indifferent by staying silent, or do we risk something far worse by speaking too loudly? Another layer complicates this dilemma: time. 3I Atlas has already left. By the time scientists debated whether it was worth attempting communication, the object had receded beyond our reach. Any signal sent in its direction would chase a ghost, perhaps never catching up. But the broader question lingers. What about the next one? Oumuamua came, then 2I Borisov, then 3I Atlas. More will follow. Perhaps hundreds or thousands more over the coming centuries. Will we treat each as a potential messenger, or will we learn to let them pass in silence? Humanity's response might also be shaped by collective psychology. There are those who dream of contact, who imagine a cosmic kinship waiting just beyond the veil. They believe communication could bring answers to our greatest questions: the nature of life, the destiny of civilizations, the meaning of intelligence itself. For them, sending a signal is not just an act of science, but one of hope. Others are haunted by darker visions, where our first contact is also our last. In their view, silence is not cowardice, but survival, a strategy not unlike that of a small creature remaining still in the shadows, knowing that predators roam nearby. Philosophers sometimes frame this dilemma as a mirror of our own history. When technologically advanced civilizations met less advanced ones on Earth, the results were often catastrophic for the weaker side. To broadcast recklessly into the stars may be to risk repeating this same pattern on a galactic scale, with us as the vulnerable side. Yet others remind us that stagnation can also be a kind of death. To cower in silence forever is to close the door on perhaps the most profound journey humanity could ever undertake. Ultimately, the question of response may not be answered by scientists alone. It touches governments, philosophers, ethicists, and even ordinary people. What does humanity want? Do we want to shout into the void, hoping someone kind is listening? Or do we prefer to remain a whisper, cautious and unseen, until we understand the universe better? Perhaps the truest danger lies not in speaking or remaining silent, but in failing to agree, in sending mixed signals born of a divided planet. A civilization fractured cannot present a unified voice to the cosmos. And so, 3I Atlas becomes a symbol, not just of interstellar wanderers or mysteries of astrophysics, but of our own uncertainty. It reflects the tension between our yearning for connection and our fear of consequence. For now, silence remains the default, not out of a carefully chosen policy, but out of necessity, as the object has already vanished into the dark. But the next time one appears, humanity will face the same choice, and perhaps with greater urgency. Will we reach out, or will we hide? In that moment, our response will not only define how others see us, it may determine whether we survive to ask the question again. The risk factor in considering 3I Atlas as something more than just a natural interstellar visitor is a sobering one, because it forces humanity to confront a question that has haunted the search for extraterrestrial intelligence from the beginning. If someone or something is out there, is it safe to let them know we exist? If 3I Atlas is only a wandering fragment of rock and ice, then it is nothing more than a cosmic tourist passing through, a reminder of the vastness of space and the diversity of what it holds. But if it is something more, if it is engineered, guided, or seeded with intent, then our reaction to it might determine not just our understanding of the universe, but the fate of our species. Responding recklessly could draw attention we may not want. Silence, however, may mean surrendering an opportunity for contact. It is a delicate balance of hope and fear, opportunity and risk. Imagine that 3i Atlas is an observation platform, a probe disguised as a harmless fragment, quietly measuring, watching, and then transmitting its findings back to its creators. The very act of acknowledging it, of sending signals directed toward it, could serve as proof to whoever placed it here that humanity is intelligent, aware, and perhaps even worth engaging with. That sounds exciting on the surface, but it also carries a darker possibility. Revealing ourselves might make us vulnerable to forces far beyond our comprehension. Civilizations advanced enough to send objects across interstellar distances are by definition operating on technological scales we can barely imagine. They would wield energy, knowledge, and methods of travel so far above ours that any attempt at defense would be meaningless. By reaching out blindly, we could be inviting not dialogue, but domination. History itself provides a cautionary tale. When technologically advanced societies encountered less advanced ones here on Earth, the results were rarely balanced exchanges of culture. More often, they ended in conquest, exploitation, or extinction. The risk factor of sending signals to 3i Atlas is that we may be repeating that same pattern, only on a cosmic scale. From their perspective, we might not be seen as equals, but as curiosities, resources, or simply irrelevant life to be brushed aside. They may not even think in terms of morality as we understand it. What seems like survival to us might be inconsequential to them. The fear is not of alien malice specifically, but of alien indifference. The danger of becoming an afterthought in the plans of a species whose concerns extend far beyond our small blue world. But there is also another angle to the risk. What if responding does not attract attention at all, but instead marks us as too primitive, too naive to warrant contact? Silence might buy us more time to grow, to advance, to reach a stage where our species is ready to meet others as something closer to equals. The argument for restraint comes down to patience and self-preservation. If we send signals now, we cannot control who receives them. Perhaps 3i Atlas is not even connected to any intelligence at all. Our broadcast might travel beyond it, to be intercepted by others whose intentions we cannot predict. In trying to speak to the unknown, we risk alerting the wrong listeners. And yet, there is a counterpoint to that fear. Some argue that it is already too late to hide. For over a century, Earth has been leaking signals into space: radio, television, radar, communication satellites, all radiating outward like a cosmic beacon. The very existence of our oxygen-rich atmosphere has long since betrayed the fact that life thrives here. If a civilization advanced enough to send interstellar probes is watching, they already know about us. In that case, our silence may not protect us, but only make us seem timid, unwilling to reach out when the chance arises. Perhaps, some argue, the greater risk is not responding at all, for silence might mark us as a species unwilling to engage or unworthy of attention. Still, the possibility of risk hangs heavy. If 3i Atlas is artificial, what is its purpose? A benign probe might simply observe, but a more strategic probe could be designed as a test to see how a young species reacts under pressure. Do we panic? Do we reach out in fear? Do we ignore it entirely? Our behavior could itself be the experiment, the measure by which more advanced watchers decide how to treat us. In that sense, the risk is not only in responding, but in how we respond, whether we broadcast desperation, aggression, or calm intelligence. Each signal we send, each decision we make, becomes part of the profile that defines humanity in the eyes of another civilization. Some thinkers go further, suggesting that responding might be less about risk to us and more about risk to them. If an advanced civilization seeded 3i Atlas here, it might be watching carefully for hostile or unpredictable species. A reckless broadcast of power or signals filled with hostility could mark humanity as dangerous, triggering a defensive reaction we could never withstand. Ironically, the risk factor might cut both ways. Our own messages could provoke exactly the outcome we fear. This tension between curiosity and caution is what makes the question of 3i Atlas so haunting. It embodies the paradox at the heart of the search for extraterrestrial intelligence. We want to know, but knowing comes with consequences. To stay silent is to remain in ignorance, perhaps forever, watching as these fleeting visitors pass by without revealing their secrets. To respond is to roll the dice with the future of our species, betting everything on the hope that whoever hears us will be kind, curious, and open to peaceful exchange. The risk is magnified by the unknowns. We do not know how often such objects pass through, or how many might already have slipped by unnoticed. We do not know if they are random fragments or carefully placed instruments. We do not know if the galaxy is full of civilizations eager to communicate, or if it is dominated by silent, watchful powers who prefer that emerging species like ours remain in the dark. Each of these unknowns turns the question of response into more than a scientific decision. It becomes a philosophical and existential gamble. Perhaps then, the wisest approach is caution. We can study, we can observe, we can watch the skies for more interstellar visitors. We can prepare our own technologies, advance our understanding, and decide as a global civilization what kind of message we would send if the chance ever came again. But to respond hastily, to shout into the dark without knowing who listens, carries risks that could outlast our civilization itself. The stars are vast and ancient, and if something out there is already watching, it has the advantage of patience. The question for us is whether we can match that patience, or whether our curiosity will drive us to take risks we cannot take back. It is often said that the universe reveals its secrets in whispers rather than shouts, and few things embody that truth more than the brief visit of objects like 3i Atlas. They arrive suddenly, streaking into our solar system from the deep blackness of interstellar space, and by the time we realize they are here, they are already on their way out, fading back into the void from which they came. For 3i Atlas, this meant that humanity had only a small observational window, a fleeting glance at what might have been one of the most important discoveries in history. Telescopes were turned, instruments calibrated, data collected as quickly as possible. Yet the object's sheer speed and the vast distances involved ensured that what we gathered was more like a snapshot than a full portrait. We are left with fragmentary information, blurry impressions, and tantalizing hints that can be interpreted in many ways, but never definitively proven. That gap between what we saw and what we could have seen is the very essence of a missed opportunity. It is difficult not to feel a kind of cosmic frustration. Imagine, for instance, if 3i Atlas had passed closer, if it had lingered longer, or if we had noticed it earlier in its trajectory. With more time and better positioning, astronomers could have aimed our most powerful telescopes directly at it, tracking every detail of its motion, its rotation, its composition. Perhaps we could have sent a probe, like a rapid response mission designed to intercept and examine such visitors up close. But reality gave us no such luxury. By the time the discovery was confirmed and debated, the object was already slipping away at a pace that no current spacecraft could match. What remained was a fleeting trail in our detectors, a few data points to argue over, and the haunting question of what we had just witnessed. This sense of loss is magnified by the possibility that 3i Atlas might not have been entirely natural. If it was simply a shard of ice and dust, a leftover fragment of planetary formation from some distant star system, then perhaps we lost nothing more than an interesting but ordinary rock. But if it were something more, an artificial object, a probe, a beacon, or a vessel cloaked in the guise of nature, then what we missed could have been our first chance at direct evidence of other civilizations. That possibility sharpens the edges of regret. Because while the scientific consensus leans toward natural explanations, the gaps in our knowledge leave the door wide open for speculation, and speculation thrives in the spaces where data is thin. The tragedy of such missed encounters is that they are not rare in the universe's grand design. Objects like 3I Atlas and Oumuamua are likely only the first of many interstellar visitors we will notice now that our instruments are sensitive enough to detect them. For billions of years, countless such fragments may have passed through our solar system unnoticed, ghosts slipping silently by while Earth remained oblivious. It is only in the last sliver of cosmic time, with our telescopes and detectors finely tuned, that we have begun to realize the richness of this hidden traffic. And so each sighting feels like a gift, a revelation, but also a reminder of all the countless opportunities we have already missed. The real weight of these fleeting moments is not just scientific, but philosophical. They remind us of our fragility, our unpreparedness, our position as a young species just learning to look outward. The universe will not slow down for us. It will not wait for us to catch up. When a visitor like 3I Atlas sweeps through, it is up to us to seize the moment, and if we cannot, then we must live with the uncertainty it leaves behind. We can measure its orbit, we can estimate its speed, we can track its fading glow as it disappears, but the deeper questions, where it came from, what it truly is, and why it came, remain unanswered. This is why many astronomers argue for readiness. They say that our response to 3I Atlas and Oumuamua has shown how vulnerable we are to cosmic chance. We need faster recognition systems, rapid response missions waiting in the wings, spacecraft capable of intercepting interstellar objects on short notice. Because the next time such an object passes through, we may not want to rely on chance observations alone. We may want to send something to meet it. We may want to peel back its mysteries before it vanishes again. And yet, even with all that preparation, there is no guarantee. These visitors are rare and unpredictable, and the cosmos is not on our schedule. In the end, what 3I Atlas leaves us with is not certainty but wonder, and perhaps a bit of longing. Wonder, because it reminds us that the universe is alive with motion, with objects crossing unimaginable distances to appear suddenly in our skies. Longing, because in those moments when something so mysterious brushes past us, we cannot help but wish we had just a little more time, a little more clarity, a little more access to the truth. The fleetingness of the encounter is what makes it beautiful, but also what makes it painful. We are, in some sense, like astronomers standing at the edge of a vast ocean, watching ships appear briefly on the horizon before slipping away into fog. We see their outlines, we wonder where they came from, but they are gone before we can ask their names. 3I Atlas was one such ship, passing silently through our cosmic waters, leaving behind ripples in our instruments and endless questions in our minds. Did we miss a chance to know something extraordinary? Or did we simply glimpse another shard of the universe's debris? The answer remains out there, untouchable, as the object itself drifts further and further beyond our reach. And so humanity waits, watching the skies, hoping that the next time a stranger arrives from the stars, we will be ready. Because the story of 3I Atlas is a reminder that opportunities in the cosmos are not endless, and once missed, they do not return. It is both a humbling lesson and a powerful motivation to prepare, to build, to look more carefully, and to listen more deeply. For the universe is whispering still, and perhaps one day we will catch more than a whisper. Perhaps we will finally hear the full message that has so far eluded us. When we speak of 3I Atlas, the third known interstellar visitor to slip briefly into our solar system, we can't help but wonder how much more we might have learned if only we had better tools. Our instruments today, while powerful, are still limited by time, sensitivity, and positioning. The universe doesn't schedule its mysteries around us. These objects come when they come, unannounced, gliding through the solar system like silent ghosts. By the time we notice them, they're often already on their way out. But the next generation of telescopes promises to change that dynamic, shifting us from passive spectators of cosmic chance to active watchers, capable of catching more of these wanderers early enough to study them in unprecedented detail. Right now, projects like the Vera C. Rubin Observatory are being prepared to begin scanning the night sky with astonishing breadth and depth. Unlike current sky surveys, which are often limited to smaller patches of space or constrained by narrow observation windows, the Rubin Observatory will map the entire visible sky every few nights. That means the sudden streak of an interstellar interloper, like 3i Atlas, will be far less likely to escape our notice until it's already gone. Instead, we may spot them as they're still inbound, approaching the solar system, weeks or even months before they swing past the sun. Such an early warning could be transformative, giving astronomers the time they desperately lacked in the case of Oumuamua, 2i Borisov, and 3i Atlas. But telescopes are only part of the story. Imagine pairing such detection systems with rapid response missions, spacecraft designed to sit on alert, ready to launch at a moment's notice when an interstellar visitor is detected. These probes could intercept the object, fly alongside it, and gather data up close: images of its surface, measurements of its composition, readings of its temperature and rotation. It would be the difference between squinting at a blurry photograph and walking up to shake someone's hand. In fact, some scientists have already proposed this concept, envisioning a fleet of small, nimble spacecraft parked in orbit or even stationed at strategic points in the solar system, ready to spring toward any visitor that enters our neighborhood. If 3i Atlas was just a faint blur in our telescopes, the interstellar objects of tomorrow might become fully resolved worlds in our cameras. The future isn't limited to telescopes on Earth or interceptors in space. Upcoming space-based observatories will play a crucial role too. The James Webb Space Telescope, while not designed specifically for this purpose, has already proven it can turn its gaze toward unusual moving targets. Future instruments, even larger and more specialized, could make such observations routine. If a visitor emits heat, reflects light in unusual ways, or carries trace gases that suggest an active surface or sublimating ice, we will have the sensitivity to detect it. The faint signatures that eluded us with 3i Atlas could be captured with clarity. What's especially tantalizing is the sheer number of such visitors we may find once our detection methods improve. The three we know, Oumuamua, Borisov, and Atlas, might just be the tip of the iceberg. For all we know, thousands pass through the solar system over centuries, most of them too faint, too small, or too swift for us to notice with current instruments. With the Rubin Observatory scanning endlessly and other telescopes joining the hunt, we may discover that the cosmos regularly tosses us these messengers from other stars. And with every new object comes the chance that one may carry something extraordinary, some hint of an origin beyond natural processes. There's also the matter of preparing for what we might find. If a future object is indeed artificial, or even just strongly suggestive of advanced engineering, how will we respond? Will we treat it as evidence that we are not alone? Or will we insist on pushing the natural explanation as far as it will go? Improved telescopes may not settle the debate immediately, but they will bring us closer to clarity, stripping away layers of uncertainty that clouded our observations of 3i Atlas. We may soon be able to determine whether these objects are inert rocks, icy fragments, or something far stranger, silent machines drifting with purpose. The potential of future watchers extends beyond just discovery. They will help us place ourselves in a wider cosmic context. If we begin to see patterns in the types of objects entering our solar system, it may reveal something fundamental about galactic dynamics. Are these visitors common debris scattered by the chaos of planetary formation in other systems? Or are they rarer, pointing to unusual processes, or even deliberate action far beyond our reach? Each detection adds a pixel to the picture, gradually sharpening our understanding of the galaxy we inhabit. And it's not just scientists who will watch. In the decades to come, as telescopes become more powerful and data more widely available, ordinary people may be able to track interstellar objects in real time, watching their trajectories unfold in digital sky maps. The discovery of 3i Atlas was obscure, known mainly to a niche group of astronomers, But future discoveries might play out on a global stage, with billions of people aware and invested in what passes through our solar system. The sense of shared curiosity, of collective wonder, could become a defining feature of our age. The moment when humanity became aware not only of its place among the stars, but of the visitors who occasionally pass through. Looking ahead, it seems inevitable that we will see more of these messengers. The question is, how ready we'll be to greet them. With better telescopes, rapid response missions, and an openness to what the data might reveal, we may finally step out of the frustrating cycle of missed opportunities that defined our encounters with the first three. The future watchers will not simply see, they will act, intercept, analyze, and perhaps even uncover truths that rewrite our understanding of what it means to live in a galaxy filled with countless stars and endless possibilities. If 3i Atlas was a fleeting shadow, then the visitors yet to come may be full portraits, objects we can study with depth, with precision, and with wonder. For the first time, we may truly come to know our galactic neighbors, whether they are stones, comets, or something far stranger than we ever dared imagine. What if 3i Atlas wasn't the first? What if this strange traveler is not a singular event, not a rare cosmic accident, but part of a much larger pattern we've simply been too limited to perceive? The unsettling thought emerges. What if they've been here before, quietly slipping through the solar system, watching, recording, and leaving no trace of their passage except a faint trail of mystery in the minds of those who dared to imagine more? For most of human history, our ability to look outward was so primitive that countless visitors could have come and gone unnoticed. Before telescopes, before satellites, before modern observatories, the sky was little more than a tapestry of fixed points and wandering planets. If an object like 3i Atlas passed by in the 9th century, in the age of Vikings and castles, who would have known? At best, it might have been mistaken for a faint comet, recorded in some forgotten manuscript, its true interstellar origin never suspected. Even in the past century, our technology wasn't sharp enough to track small, fast-moving objects against the overwhelming background of stars. Only in the past few decades have we reached the point where something like 3i Atlas could even be identified as an interstellar body, which means, statistically, we may already have missed countless others. Perhaps dozens, perhaps hundreds, have already cut through the solar system in silence, each one a potential messenger, a probe, or simply a shard of alien geology, passing by like ships in the night. The chilling part is not just that they might have been here before, but that their presence could have gone entirely unnoticed. It raises the question, are we only now waking up to a reality that has existed for millennia? The what-if deepens when we consider intent. If these visitors were artificial, if they are in fact watchers, they may have deliberately avoided detection. An advanced civilization capable of sending interstellar probes would also be capable of stealth. Imagine a vessel designed to appear perfectly natural, its surfaces mimicking the reflectivity of ice and dust, its orbit carefully calculated to avoid raising suspicion. Humanity, still primitive in cosmic terms, would look at it through telescopes and declare it a comet. Meanwhile, it could be listening, transmitting, or even testing our reactions. If that is the case, then perhaps this is not the first time Earth has been observed. Perhaps such scouts have been gliding past since long before we could grasp their significance. And if so, then the implications are staggering. What if they've been monitoring humanity's progress all along, checking in every few centuries, watching us evolve from stone tools to cities, from fire to electricity, from radio waves to spaceflight? The timeline becomes eerie when you think about it. We develop telescopes just in time to notice. We build powerful observatories just as the first interstellar objects start being recognized. We might believe this is coincidence, but what if it isn't? What if this is part of the test? If they've always been watching, but only now are allowing themselves to be seen, measuring how we respond? Even more unsettling is the possibility that we've recorded them without realizing it. ancient star catalogues, strange mentions of wandering stars in old texts, unexplained celestial events noted by astronomers centuries ago. Any one of these could have been a passing interstellar visitor. Some were likely just comets, but can we be sure all of them were? What if our ancestors unknowingly documented previous encounters, and the evidence has been sitting in dusty archives, disguised as folklore or misclassified astronomy? The big what if is not just a thought experiment. It's a reminder of our blindness. We assume 3-Eye Atlas is rare, extraordinary, perhaps the first of its kind. But what if it is only the latest? What if the sky has been full of such silent watchers all along, slipping past us under the cloak of our own ignorance? The truth is, we cannot say for certain. And that ignorance is perhaps the most haunting part of all, that we may have already been visited, not once, but many times, and never even knew. What lingers at the edge of thought after all the speculation and analysis is not the mathematics of orbits or the physics of interstellar debris, but the possibility of intent. For all our calculations that showed 3-Eye Atlas speeding past the Sun, bending only slightly under its gravity before resuming its silent journey, there remains a nagging doubt. What if the story we tell ourselves about passing through is incomplete? Perhaps its trajectory was never random, never a product of chaotic ejection from some far-off star system. Perhaps it came with purpose, and its fleeting presence in our skies was not accidental at all. Imagine the unsettling alternative, that 3-Eye Atlas wasn't simply crossing the solar system on its way to nowhere, but stopping here in the most inconspicuous way possible. A pause so subtle we never recognized it as such. A calibration in motion, just enough to linger, just enough to observe, before vanishing again into the black sea of interstellar space. The thought turns the object from a curiosity into something more deliberate, as if we had been studied under a lens we didn't know existed. And if that were true, what did it see? Our towers of steel rising above crowded cities, our fragile satellites circling Earth like fireflies, our voices spilling across the cosmos as radio waves leaking into the dark. It would have witnessed a species loud and restless, intelligent enough to build machines that can watch the skies, but naive enough to assume that watching is always a one-sided act. We look outward, believing ourselves to be the hunters of knowledge, but perhaps in that moment, we were the prey under quiet examination. This closing reflection invites us into an uncomfortable silence, because if 3-Eye Atlas did pause here, then it left not because of chance or gravity, but because it had seen enough. And that is perhaps the most chilling thought of all, that its purpose was completed, its mission fulfilled, and its departure was not escape, but conclusion. We were measured, catalogued, and left behind, with no assurance that silence means safety. So the next time a faint speck drifts into our solar system, carrying the signature of an interstellar traveler, we will remember 3-Eye Atlas. Not as a random visitor, but as a reminder that the universe may already be watching us, and that sometimes the watchers leave no trace except the haunting suspicion that they were never really gone at all. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.